Okay. So the recruiting is started. So now you can see the slides, right?
Yes, sir.
Okay. So good afternoon, everyone. So today we'll be discussing about week 6 assignments of previous years. So we'll be discussing few questions from previous year's assignment of week 6, which generally deals about the trajectory problem or trajectory planning problem for robotic systems. And I will also discussing one of the questions which you have already asked in last class about week 4 assignment of this year's question number 11. So I will also explain why the answer is given, what is given. So let us first discuss that question, and then we'll discuss week 6 question. So with that, let us start today's session. So the first question for today's session is as follows. So this is basically the question number 4 of week. Oh, sorry. Basically, question number 11 of week 4 assignment of this year's. So the question is given as follows. So given below is the schematic diagram of RR manipulator. So here we are talking about an RR manipulator. So this is base frame, and then RR manipulator is given as follows, and theta 1 and theta 2 is given, theta 2, and this is theta 1, right? So and here choose the correct condition for singularity. So for singularity, you know that J, that is Jacobian, that means determinant of Jacobian should be 0, right? So you must have gone through that. So what is Jacobian then? So first you have to write in terms of x and y expression, in terms of what? Joint parameters like theta 1 and theta 2 here. And then you have to find the matrix dou x dou theta 1, dou y dou theta 1, sorry, dou x dot theta 2, dou y dou theta 1, dou y dou theta 2, right? So if you write the x expression, what will you get? You'll get here like x. If you're taking this component here, so it will be L1 cos theta 1 plus L2 cos theta 2, because this theta 2 is basically the angle which is made by the from the x naught. So it is not similar to the case which you have already last time when you were discussing, you are saying that this is not the same as what it is shown in the slides. But in slides, the thetas are defined based on the previous frames, right? Like this. That's why you could have got this expression like theta 1 plus theta 2. But here you will not get, because this theta 2 is basically defined in terms of x naught itself. So you can directly write like this: x is L1 cos theta 1. So that will be here this distance plus L2 cos theta 2. That means this component. So that means that will give the x position of this. And similarly, you can write y is equals to L1 sine theta 1 plus L2 sine theta 2. Now, if we write the Jacobian, what we'll get? So Jacobian will be nothing but dou x over cos theta 1 will be what? Minus L1 sine theta 1, and this will be minus L2 sine theta 2, and this will become L1 cos theta 1, L2 cos theta 2. Now,
Sir, hello.
yes,
Sir, that x is equal to L1 cos theta 1 plus
uh,
L2 into cos of theta 1 plus theta 2 only, no, sir?
no, no, no. So that's why
That's
I was
not
saying that
delay.
this theta 1 plus theta 2 will come when this thetas are defined in terms of the previous link direction. So here it is defined like this, no? You can see here. So this is what? This is parallel to x naught. So basically it is given in terms of x naught, and all we need is that we want a position of x and y in terms of x naught and y naught. So this theta 2 is the angle made by from x naught. So if you're taking component in x naught, you will directly take theta 2, right? Not theta 1 plus theta 2. Understood?
Okay, sir.
Understood or not? So this is
Uh,
x naught, right? And this is parallel. So the theta 2 is the angle made from x naught itself. So if you are taking the component in x naught, we can directly write L2 cos theta 2 to represent this length, and L1 cos theta 1 to represent this length. And this length plus this length in the x direction will be representing the x component. Similarly, y component can be added this one and this one. Understood?
Understood, sir. Understood, sir.
Yeah. Yeah, that's why the like whatever answer you are comparing last time, you are getting confused. So here, if you try to find this determinant and you try to make it to 0, you'll find that theta 1 should be equal to theta 2. That is one of the condition. And here, as theta 1 is given to pi by 2, so theta 2 should be also pi by 2. So the correct answer for this question will be uh, pi by 2. Understood?
Yes, understood, sir.
Okay, good. So I hope it's clear. The last question. So of the this week, this year's week 4. So with that, let us move to the next question, and that question will be of the last year's week 6 assignment. So with that, also we will be starting week 6 assignment. So the first question for the week 6 assignment is, or previous year 6 assignment is, that this is a true and false statement question. So the question is, the desired trajectory of the joint or the manipulator should be one differentiable, right? So this is what it is given in the sorry, the statement. So uh, when we try to plan a trajectory for any robot, so suppose this manipulator robot or something, anything. So we always try to have this motion or the transition from this point, suppose A to this point, that should be what? Is in some sense it should be smooth, right? So for the smoothness, what we should know, for smoothness, the path which we'll be defining should be at least differentiable in differentiable, and that also C2. That means twice differentiable, so that it, in some sense you will get a smooth enough at least acceleration level. So that the changes from A to B will be some kind of smooth, and that is desirable. So here the statement says that the joint or the manipulator should be, the desired density should be once distributed, which is not the exact constant. Rather, we need a twice differentiable. So this will give a very smooth trajectory in some sense. If we can have more than twice differentiable, then that would be advantageous. But in fact, if you keep on increasing the order or degree for the trajectory, that will lead to what? Lead to higher computation power required. So higher computation. So that is generally avoided. So whatever you have gone through the lectures, it will be have been shown by either 3 or 5 degree, and we don't go beyond that because that is not required in most of the cases, and also it will increase the capacity. So, but in any way, we need a twice differentiable. So here it is saying only one differentiable. So the this statement is false. So this is how we get the answer for this question. Now moving forward, the next question. The next question is also a true false statement. Here, the is saying that the best trajectory between 2 points is based on a straight line interpolation, that is constant velocity motion in terms of smoothness. Again, this is very much linked to the previous question. So, straight line interpolation, that is constant velocity. So, it's kind of showing that A and B point will have the manipulator will be moving from A to B in some constant velocity. So, so but so that is fine. We can have a plan or a trajectory to move into the constant velocity from A to B. But it is saying that that is based on that in terms of smoothness, it is the best. No, that is not the best, because we can have this from A to B. You can have some type of parabolic or some other type of trajectory which are more smooth, and there will not be any kind of jerk which you can feel throughout from A to B. So this is possible, but this is not the best trajectory. So what it is shown here is that the best trajectory between 2 points is based on straight line interpolation, that is constant velocity motion in terms of smoothness. So in terms of smoothness, this is not best trajectory. In fact, if we keep on uh, increasing the what order of the polynomial, the smoothness will increase. But again, the computation also you have to think about. So computation will also increase. So you have to always, what you have to do, you have to take a, or you have a trade-off, and you have to choose what you want. You want your smoothness to increase, or you want to have a look into the computational capability of the robot or the system which you have. So based on that, you make a decision. But in any way, this is not the best in terms of smoothness. So the correct answer for this question is false. That is written here. So this is the correct answer. Now with that, let us move to the next question. So the next question is that against true false. The fifth order, this was the fifth order polynomial function is called a quintic polynomial. So this is just a general knowledge for basically when you have gone through this lecture, you know that the fifth order is known as quintic. So there's nothing to look into this. So the correct answer is true itself. So the third is what? Cubic. So three order is cubic. Two is quad, and similarly fifth is quintic. So this is just a terminology, and if you know that yes, fifth known is quintic, so that's it. It's true. Moving on, moving to the fifth question for the today. So that is that the initial joint position is given. So if you write it here, theta equals to 20 given, and theta f equals to 50 degrees given, right? So these two is given, and if the initial and final velocity is 0, that means theta dot I equals to 0 and theta dot f equals to 0, right? And tf is 5 seconds. So this is given, that means t0 is what? 0. You can assume that that we are starting at t equals to 0. So if you see this, what will happen that what else is given? I think we have written everything. So it is asking what is the maximum velocity of the trajectory if cubic polynomial is used. Now it is saying that a cubic polynomial is used. So what you can write? You can write that theta must be a function of what? Like this, at cube plus bt square plus ct plus t, right? This is cubic, right? So you can write this theta as one. Now using the given condition, you can find the coefficient a, b, c, and d. And how will you do that? So let us do that. So that is a function of t. So theta of 0 is what? Theta I, that is 20 degrees. So if you put t equals to 0, we'll get what? D, that will means 20. So one coefficient you got. Then again, if we write theta of 5, that will be what? Theta of 5 will be nothing but theta f, that is 50 degree, and that will be equal to what? 125a plus 25b plus 5c plus 20, that is d. And then if you move it here, what will get? 125a plus 25b plus 5c, that equals to 30. So this is one equation we'll get. Then what we'll do, we'll differentiate this. So if you differentiate, what will you get? 380a square plus 2bt plus c, right? Now theta dot to 0 is what? 0. It is given. So what we'll get? If we put 0, you'll get c equals to 0. So that is one thing. So so this can be further written as 125a plus 25b equals to 30 as c equals to 0. Now theta f, that means theta dot f, that is also equals to 0. So you have to put 5 in place of t, because f is nothing but 5 seconds after that. So theta dot of 5 equals to 0. That means 3a into 25 plus 2b into 5, right? As c is equals to 0, so you don't have to write c. So what we'll get? 125, no, 75a plus 10b, and that is equals to 0, right? So from here, so these two equation we have. So what we can do, we can put it this, we can solve these two equation and we'll find a and b, and we know that c is 0 and d is 20, and then we can have this polynomial, and then we can find. So uh, what we'll do, if you solve this, you'll get, what we'll get, you'll get a equals to minus 12 by 25, and what we'll get b, b will get as minus 7.5a, 5a, right? So b will be minus 7.5, because if you move this this side, and if you take the b will be minus 7.5a. So now here it is asked at maximum velocity. For maximum velocity, so we know that if you want to find the maximum of some function, we have to take another differentiation and see when, and then we have to find the time when it is becoming 0, right? So for that, what you have to do, or rather, you know that this timing will be nothing but the, if you're taking these two trajectories, this maximum velocity will occur in the middle of the time, right? So this the middle of the time is nothing but 5 by 2. So no need to find this time itself. You can use this 5 by 2 second and you can plot. So now theta dot is the velocity, which is nothing but 3a t square plus 2bt, right? Now we have 3a, that is 3 into minus 12 by 25, and t square is nothing but 5 by 2 k square plus 2 into minus 7.5 into a is nothing but minus 12 by 25 into t is 5 by 2. So what we'll get here, if you solve this, we'll get this 25, this is a square, so what will happen, this will be 25 by 4. So 25, 25 gone, 3. This will become minus 9, and 5, 5 to 6, and this will become what? This will become 18. So if you multiply this and divided by 5, this will become 18. So we'll get nothing but minus 9 plus 18, that is 9. So theta max, or rather theta dot max, will be nothing but 9 degree per second. So this we got. So because we know that this maximum velocity will occur when the time in between the time. So that means the total time is 5, the in between time will be 5 by 2. So we have first find out the polynomial representing the maximum, or representing the velocity, and then we have find out this all the coefficient, and then using this time we have find out the theta dot max, that is nothing but 9 degree per second. So hopefully you have got this idea. The rather, if you don't know that it will happen in the middle of the time, you can also do that. You can again differentiate, that means you find theta 2 dot, that will become what, 680 plus 2b, and equate it to 0 to find t, and that will be nothing but it will come as tf by 2. So in that way also you can find, because you know that if you given a function, if you differentiate it and equal to 0, and then at that time you'll have either minima or maxima, that you have studied in class 12. So using that also you can find that. So hopefully you have got this question as well. So let us move to the next question. So the correct, first of all, the correct answer for this is 9 degree per second. So let us move to the next question. The next question is basically again a true false question. So for a trajectory with k via points, in order to get smooth acceleration at via point, the velocity of the via points must be uh, specified. So that is what is given. So in order to get a smooth acceleration at via points, so you have gone through that. So suppose this is A and B, and there is some wire points in between. So if we have wire points, we'll again have, so what we'll do, we generally plan from that wire points, and then this continuous trajectory from here to here, and then try to find the here, and again from here to here, something like that. So the for trajectory with k wire points, in order to get smooth acceleration at wire points, the velocities of the wire points must be specified. Okay, so this is not always the true case, because uh, if you plan from here to here, all we need is that we have the enough number of equation for finding the what you can say this finding the unknowns or unknowns. So like theta is from something like at square plus bt at cube plus bt square plus dot 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 dot, something like that. So all we need is we have to find these all coefficients. So we should have enough number of equations to get that. So that's why we need to specify that at wire points what are the conditions. But generally, when in order to get but when we want a smooth acceleration, not only this velocity of the wire points will be specified, rather the acceleration should be specified, so that we can get a smooth acceleration. Because that means that whatever acceleration is here, that will be the same acceleration here when you start from the new wire point. From this, suppose this is k minus 1 wire point and this is k. So k minus 1 to k wire points. So at the end of the k minus 1 wire point, at the starting of the k minus 1 wire point, the acceleration should be what? Same. Then only you can say that there is a smooth acceleration. So similarly for this wire point, this wire point. So all you need is that we should have the specified acceleration, or rather, uh, we should have a uh, same or continuous acceleration from each wire point, so that we'll have a smooth acceleration. So this is the what the condition, rather than the velocity of the wire point must be specified. So this is what we need. So the answer for this question is false, because for smooth acceleration we need to have this solution. Each wire point is starting and end of that wire point. If you're looking from the backward, the end of that wire point and the start of the wire point, that means here and here, the solution should be same. Similarly here. So the correct answer for this is false. Now moving forward, now we have question number 7. So for a given single rotatory limb manipulator, the initial joint position is 30 degree, and the final joint position is 70 degree. So this is what it is given. So, and it reaches the final position in 20 seconds. So let us find out how. So we need to find the theta of t. Now this is third order polynomial it is given. So again we can assume at cube plus bt square plus ct plus t, right? And now we have given this condition, f is given, and also for the initial and final velocities are given. So again let us find theta dot t, that is 3at square plus 2bt plus c, right? Now theta 0 is 30, that implies d is 30. It is fine. If you put 0 here in the first equation, you'll get all this will become 0, d will become equals to what? Nothing but 30 degree. So you get d equals to 30 degree. Now theta 20, if you put 20 here, what you'll get? You will get 8000 a plus 400 b, as this time is t, so 20, so we can write like this, plus 30, that is d equals to 70. So if you further simplify, what will get? 8000 a plus 400 b equals to 40, right? So this is one of the equation. Now theta dot t equals to 0, initial and final both. So theta dot 0 will be nothing but C, nothing but C. Because if you put 0 here, this will go, so only C will be there. And that is nothing but equals to 0 as it is given initial velocity as 0. And theta dot 20 is also 0. That implies that 3a square, oh sorry, 3a t square, right? So 3a t square, that means 20 square is nothing but 400 plus 2b into 20 equals to 0. So from here, if you get, what you'll get? You'll get 40 minus 40b. If you send this that side, minus 40b equals to 1200a. This will go and this will become 30. So b will become minus 30a. So b will become minus 30a. So if you put this here, what will get? 8000a plus, or rather minus 12,000 a equals to 40. This will become what? Minus 4,000 a equals to 40. So a will become 40 by minus 40,000 or 4,000. This will become 0. This will be minus. This is minus 0.001. So a will be this one. So b will be what? Minus 30 into minus 0.01. That will become what? 0.3. Right? So A is this, B is this, and C we have got at 0, and D we have got at 30. So now we can write theta of T is what? AT cube plus BT square plus CT plus T. So we can put it here to all the coefficients. So A is what? Minus 0.01 T cube plus B is what? B is 0.3 T square plus C is what? C is 0 plus D is 30. So it will be, it can be rearranged and written like 30 uh, plus 0.3 T square minus 0.01 T cube. So this is the equation for theta T. So which one is correct here? If you look, this one is correct, right? 30 to this and minus 0 T cube. So this is how we'll get the theta equation, or rather theta or the trajectory equation for the uh, given problem. And we have used this initial condition, and then again the initial condition or the initial velocity and final velocities. So these four conditions we have used to find all the coefficients and also the time we have used. So, and then we'll have got this. So this is how you find out the trajectory equation. So this is what we have for this question. So with that, let us move to the next question. The next question is again a true false statement question. So the question says that the even order polynomials are not generally used in trajectory generation, and due to the mismatch with the number of unknowns and the possible equations obtained using the polynomial equation. Uh, in fact, if you've gone through the lecture, this is true. For example, so suppose if we have two points here, A and B, and if you suppose it want to make this using quadratic equation, that means A t square plus bt plus c. Suppose if you want to make theta t of it like this, here we have how many unknowns? We have three unknowns, right? Now, if we have initial condition theta I and theta f, only initial condition is specified. How many equations we'll have? We'll have two equations. So two equations, three unknowns. Now, so this is you will not be able to solve it. Now, suppose if we have this initial velocity as well, theta I dot and theta f dot, then again, here we'll have four equations, three unknowns. So this is like overestimated or even over known systems, or you can say that, you have to again is some kind of like adjustment you have to do. So basically, people can still use these quadratic functions, rather in knowing that they don't know about the theta I, but they know that at the final position theta dot f is 0. So if you have only three conditions, you will get three unknowns and three equation, and you will be able to solve. Even in this case, you will be able to solve, but you have again have to take care of that. So there is some kind of mismatch here, and it can be also even treated as some kind of handicap. So generally, to avoid this, people use odd odd order of polynomial, and that is generally third order or fifth order, and not go beyond because of the thing that computation will increase. So this is what it is. So here the even order polynomials are not generally used in the trajectory generation due to mismatch. So that means whatever we have discussed here is correct, and it is written the same way. So the correct answer for this question is true. So there is some kind of mismatch as we have seen here.
Sir,
uh, yes, hello.
sir, in third order equation also,
Hmm.
there are there are four unknowns, no sir, and three equations, no sir.
Where in fourth order?
In third order, three
uh,
equations and four unknowns, no sir.
so let me write the third order. So the third order will be what? At cube, right? bt square plus ct plus d, right? So how many unknowns are there? Four, right? A,
Yes
B,
sir.
C, D. We don't know. And what are the four conditions we have? So we, like in earlier equations we have all seen that theta I and theta f is known. That initial and final position is known, and then initial and final velocity is known. So how many equations will have form? So four equation and four unknowns. So that's, it's not a kind of handicap, as you can have also seen here, right? We have used four equations. So
Uh,
directly I find out c equals to 0 here, d equals to 30 here, and then these two equation. So four equation and these four unknowns. We found out now C, D, A, and B. So C,
yes sir.
given the condition, C comes out to be 0. That's why I think you have been confused that we don't have C here, only 3. But it comes out to be 0 given the question or the conditions. But it is not always the case. So generally we'll have uh, four unknowns and four uh, boundary condition like theta I, theta f, and theta I dot and theta f dot. And if for the fifth order, we also include theta I double dot, theta f double dot, and so on. We can include. Understood?
Sir, that means power three means not three equations like that, no sir.
No, no, no. So
Uh,
degree means that the maximum power of that equation. So maximum. So this is the variable, right? T. The maximum power is what? 3. So that is known as the degree.
okay
Third
sir.
order. Order.
Okay sir.
So this is third order polynomial. Understood?
Understood sir.
Okay, good. So let us move to the next question. So next question is for a given single rotatory. I think someone is there in the lobby. Let me include it. Okay, I think I have included you in the this. Okay, let us continue. So now the next question is question number 9. So for a given single rotatory link manipulator, the initial joint position is 30 degree. And so again, if you write theta equals to 30 degree and theta f equals to 70 degree, and it is the final position in 20. So tf equals to 20 second. The motion is supposed to be in cycloidal motion, then what will be the maximum joint velocity? Right. So this is what it has been asked. So for, as it is a cycloidal motion, so you know that x of t is written as x naught plus xf minus x naught by 2 pi tf t minus sine 2 pi tf to t. Right. So this is the equation for the sinusoidal, or rather the cycloidal motion. So here we are bothering about the joint velocity and the maximum joint velocity. So So let us differentiate it to have this velocity term. So what will be the difference? So this will go, this is as constant. So what we'll get? We'll get xf minus x naught by 2 pi into 2 pi by tf, right? Minus xf minus x naught will become, so this, if you can write it was minus xf minus x naught 2 pi, this will become cos 2 pi by tf t into 2 pi by tf using the chain rule, right? So this is what we'll get. So what will happen? This 2 pi will go, and finally we have xf minus x naught by tf, and this 2 pi will go, and this will become plus x naught minus xf by tf cos 2 pi by tf into t, right? Now we know that even if it is for the cycloidal, this maximum velocity, right? Maximum velocity from A to B will happen only in the middle, right? That means it total time is 20. The time when we'll have this maximum velocity, or we can write it T max, will be nothing but 10 seconds. So you can use that information here to find out the maximum velocity. So x dot max will be at time 10 seconds. So that will be nothing but xf minus x naught by tf plus x naught minus xf by tf cos 2 pi tf into 10. Now tf is nothing but 20 second, right? The total time. So and xf is 70 and x naught is 30, right? So you can use that here to find the maximum. So x 70 minus 30, that means 40, by tf is nothing but 20, right? Plus x naught minus x1, that means 30 minus 70, that is minus 40, right? Divided by 20 into cos 2 pi by 20 into 10, right? So this will become 2 pi, this will go, this will become cos pi, this is minus 2, this will be 2. So we'll get 2 minus 2 cos pi. Like cos pi is minus 1, so 2 minus 2 into minus 1, that is 2 plus 2, that is 4 degree per second. So the correct answer for this will be 4 degree per second. So that is the maximum, or rather x dot max, which we wanted to find it out. So the maximum velocity will be 4 degree per second. So this is how we'll get the maximum velocity for question number 9. So here we are given 30 degree as the initial, and this is the final position, and then we are given the total time. And we know that the equation for this cycloidal is given by this x of t. So we wanted a velocity. So first we have to find out the differentiation terms of t. So we find out the differentiation and we got an expression for the velocity like this. And then we know that the maximum velocity occurs at the time interval in between the time interval. So we have 20 seconds. So at t equals to 10, it will happen the maximum velocity. So using that t, we put that t into x dot t to find the velocity, and that will be the maximum velocity, and we found it as what, 4, that is 4 degree per second. So this is how we get answer for this question. Now let us move to the next question. So the next question is that for a given simple rotatory link manipulator, the initial joint position is 30 degree and the final joint position is 70 degree. So and it reached the, so again if you write theta is equals to 30 degree, theta f equals to 70 degree, and it reached the final position. So tf equals to 20 and t0 can be considered as 0. So the motion is supposed to be quintic. Now the motion is quintic, that means 5, fifth order, right, or fifth degree. So that means the equation could be of the form at5 plus bt4 plus ct cube plus dt square plus et plus f, right? So theta of t could be of this form, right? And so if you solve for that, so you will be given theta I, as we have discussed earlier, theta f, theta I dot, theta f dot, theta I double dot, theta f dot, double dot. So this will be 0 at initial and final, and this will be 0 at initial and final, and this will be given as here as 30 and 70. So using these equations, you'll be finding this, can find this all this coefficient, and then we can find the maximum joint velocity as we have done earlier. So as you have also gone through the uh, gone through the lecture, so I will not be solving this in the interest of time here, but you can solve using this condition. You can try to find all these coefficient, and you can put that here, and you will find the exact theta dot theta of t in terms of like this 85 plus bt4, so on. And you can put a, b, c, d by using this initial conditions, or rather this boundary condition. So we'll find that, and then you can find the maximum velocity using again differentiating the fourth time, or rather making it equals to. So if you want maximum velocity, you should have, you should equals theta dot double dot, that means acceleration equals to 0, and from there you find the time, and then use that time to find theta dot, and that will be maximum as you have already studied. So now here, as you have gone through the lecture, we know that this maximum occurs at the middle, and is rather 15 by 8 TF, right? So we'll be using this knowledge to solve this question directly, because we're not going through all the details to solve this equation. So we know that the maximum velocity is nothing but 15 by 8 TF, and that occurs in the middle. Now this result, if you go through the lectures, it is obtained when the initial is 0 and the final is 1. But here the final is, initial is 30 and final is 70 degree, right? So similarly, you have to scale this formula. So this difference is 1. So this difference is nothing but, this delta is nothing but 40 degrees. So you have to, what you have to do, you have to multiply that with 40. So the maximum velocity t, if you write, you can write that V max is nothing but 15 by 8, right, into TF. TF is nothing but 20 into 70 minus 30, right, the scaling thing. So that will become 15 into 40 by 8 into 20. This will become to, this will become what, 30 by 8, and this is nothing but 3.75 degree per second. So the correct answer will be nothing but 3.75 degree per second. So this is how you get max, and that is theta max. And this, so this we have used directly from the lectures, or rather you can also derive it. So in interest of time, there's no need to have the derivation, as these questions are given. We know the result, we can directly use that. That it happens at 15 by 8 TF, and we can scale it for this question, as we only need to find joint velocity. We don't have to find out the whole equation. So there's no need to go through all these things. You just uh, take the result and put the thing like TF and scale it, as here it is 70 minus 30, that is the difference, it is 40, and we'll be able to find this uh, maximum joint velocity. So this is how we get the maximum joint velocity for question number 10 and for quintic polynomial. With that, let us move to the next question, or rather the last question for today. So, and the question is that in a 2D space, if the xt is generated based on one of the smooth trajectory generation scheme, then what will be the yt based on the straight line interpolation? So it is given that this is a straight line interpolation and it's 2Ds, right? So this could be like this, right? So here xt, you know, right? And we want yt, right? And this is a straight line. So we know that, suppose we know xi xi, that is nothing but x naught here, and xf, that is nothing but xf itself, and the yi, that is y naught, and yf, that is yf itself. So if you know 2 points, so to and it's a straight line interpolation, so you know, like x naught, y naught, you know, xf, yf. So in between you can have this x and y, and that is what we all need to write, right? So in terms of y we have to write, so x of t is and y of t, right? So what will be that is, as it is a straight line interpolation, the slope of all, if you try to find the slope from using these 2 points or these 2 points, it should be same. So you can use that information to find the equation, right? So we can similarly do that. So we can write x of t, or rather y of t minus y of t minus yf by x of t minus xf, right? Y of t minus yf x of t minus xf, that will be equals to this given 2 points, the slope of these 2 points. So that is yf minus y naught by xf minus x naught, right? So if you further expand this, what will get yt minus yf equals to yf minus y naught xf minus x naught. This will go this side into multiplication, that is xt minus xf, right? If you further do this, what will get yt, this yf will go this side into plus, so yf minus y naught xf minus x naught into uh, xf xt minus xf, sorry, xf plus y of f. This will go that side. So this is what we'll get. So yt will be yf minus y naught by xf minus x naught xt xt minus x plus yf. So this would be the equation, right? And this we can have, this we have found using the straight line interpolation thing, or rather writing the straight line equation. So as we xt is given, we can similarly find a yt, so we which is nothing but this one, right? So this is the correct answer. So what we have to do, we just have to do the that if it is a straight line, these all the points are in a straight line. So if you take two pairs of points, slope will be same because it is lying on the same straight line. You have used that information and you have found the equation of the locus, or rather the equation of the straight line, or that y points given xt, we can write as it is following this straight line. So with that, we finish the week 6 assignments. We have discussed almost most of the questions from last year's week 6 assignment. I think I have left only few questions which are very much direct, or rather it's the same question which have been given this year as well. So hopefully this session will help you to solve those questions as well. In case if you not be able to solve, or if you have any questions from the previous assignments which are like given this year's and you could not understand, you just uh, write a mail. I think I have already shared my mail id. I will try to discuss those questions in the next class. If those questions are from this year's and it has been checked, then only I will discuss. Otherwise, if it is from the last year, then anyhow I will discuss those questions. So with that, I think we are done for today. Anything else, you just tell me. Otherwise, we'll end this today's class. Thank you.
Sir,
Yes.
sir, I have a doubt in Newton-Euler method, sir, that backward propagation equation.
Which one?
In
Uh,
Newton-Euler method, backward propagation equation, sir.
okay. So is there a particular thing or question in which you are stuck, or you
Uh,
want to understand the concept?
no, sir, that equation itself I have in doubt, sir. Uh, In assignments they have given the equation, sir.
Hmm.
But they assign the marks wrongly, sir. I don't know. There is a wrong in the hand notes or the assignment, sir.
Okay, I think you have already mailed me, right, about that
Oh,
question.
yes, sir.
Oh, so actually I am not, I also think that is not correct, but actually I'm not the in charge of giving the marks. So I will be only the part of discussing the question answers for this year's if it is already checked or the last year. So I mostly handle that. So I think there is some other TA who is currently handling all this checking and everything. So rather you can also write a
Yes,
mail
sir.
to Professor Sant Kumar that I have some issue. You find that mail on IIT Palakkad website or even on the course website. I think you can get. You try to
Okay,
write a
sir.
mail, or you
As
write to mail to NPTL. I don't know. In your course work, can you see some help mail? You can write to them as well.
okay, sir. But the hand notes materials are correct, sir. For the Newton
Yes, yes,
backward proportion.
yes. Most of the time, it will be very much correct because it has been verified twice and thrice, and then only it is written. So you can. So always you cannot be very much like 100% sure. You cannot say there might be some issue, but 99% of chances that hand notes is correct.
Okay, sir.
So you can also ping me if you have like, then I will also look into it and I will try to discuss it next class. If you don't get any help, I will try to discuss. Don't think too much
Uh,
about the marks if you're not able to convert it, or if somebody is not like not getting the right mail or whatever. But the thing is, at the end you should understand that concept. That is more important. But still you try to
okay, sir.
write a mail so that your marks will be increased if you're right.
Okay, sir.
Okay. Okay, thank you.
Thank you, sir.
Okay, have a nice day. Bye.